Hi everyone, welcome to our video on integration by parts. Integration by parts is used when the substitution rule doesn't work. So integration by parts, so when integrating, oops, that's not the right button. So when integrating, always try an easier method first. So step one, try a basic integration. If it's one of the very easiest ones, just do that. Okay, so that's just like a power rule problem or your e to the x. 2, then try substitution. And then 3, try integration by parts. Okay, so if a basic method doesn't work, then use substitution. If substitution doesn't work, then use integration by parts. And our substitution, just to put like an arrow over here, is using our rules for our power rules. Is trying to make it into something like this is our power rule, and then we just add 1 and then divide, and then throw that plus c on the end. Okay, so that's like that. Or we have an expression and we want to make it into e to the u du, and then we have the one other du over u is the natural log of u plus c. Okay, so that's a quick reminder. So if we could set it up like this, that's better. Integration by parts is only for specific problems. Often they'll tell you when to use it, which is real nice. But if they don't, and we're just doing integrals, random integrals, well, again, these are the 3 strategies you want to try. Well, you want to try these 2 strategies first, and then integration by parts. Okay, and integration by parts is derived from the product rule. So if you wanted to check it out, you could do that. I'm not going to do a proof, though. Let's just move on. But it is this setup where it's u dv equal, the integral of u dv equals uv minus the integral v du. And so often the way that we set it up, we'll set up a u, and we'll set up a du. So we kind of make this table. And then we'll set up dv and v. So we kind of make this square grid where u and dv, these tops, are those portions right there. And then when we start to take the right side, we do a diagonal and then another cross. So these 2 will be set up and these 2 will be set up when we set up the right side. Okay, so let me just kind of, I'll do color code. So those ones will be set up with each other and those ones will be set up with each other. Okay, and then we have to remember a little bit of an integral. Okay, anyway, so it's a whole new thing. Okay, and then when should you use it? Again, when you see a product of 2 distinct functions and substitution does not work. So let's do it on these 2 problems. So let's evaluate this integral, and this will require integration by parts. I'm going to very quickly erase this. Okay, so often if you try u, substitution, we usually let the power in the e be u. And while this isn't going to work for us because it does not change it into one of these nice ones. Okay, so if it doesn't change it into one of those nice ones, then that means substitution is no good. Okay, so I wanted to erase that. All right, well, let's break this down. Okay, so we have this integral. And when we choose our u and our dv, it all just depends on the scenario. But often it's a good idea to choose the 3x as your u. Okay, so or the algebraic one. Okay, so we're going to set u equal to 3x. And then dv then is the other portion. This whole thing is dv. So we'll set that up right here. dv equals e to the 3x. And then dx is just attached still. Okay, so with e involved, an exponential involved, u is probably a polynomial. And then dv is the exponential. So that's usually how it's broken down. Okay, and then once you set these 2 up, well, just like before with substitution, even with substitution, once you set your u up, get your du, which would be 3dx. And then dv, well, our rule for so this is doing the integral, so be careful. So we are doing an antiderivative, so don't do the derivative, be careful. So this is the antiderivative, this was derivative, so it's both in one. So this was a derivative part. From dv to v, I need the antiderivative. Well, e to the 3x's antiderivative is e to the 3x over 3. And we don't do a plus c on these problems. We just save that for the very end. All right, and so what we have in this scenario, again, this is our u dv setup there. So that first one was the u, that was our dv. And then it's equal to this formula, uv minus the integral v du. Okay, and then all we'll do, I just think, I always do this, will multiply with that one straight across, or not straight across, diagonally across. And so this becomes, so u is 3x, v was the e to the 3x over 3, and then we have minus the integral, and then I think then do just these two multiplying by each other. So our v is e to the 3x over 3, and then du is the 3dx. Okay, so we get this setup here. Notice I still have an integral. That's okay, but let's simplify. So this in the blue, the 3 would cancel with that 3. So it simplifies to be just x e to the 3x so far. And then we have minus the integral. Well, this 3 also would cancel with this 3. And we have the integral of e to the 3x over dx. Or not over, sorry, e to the 3x dx. And then this integral is now something we can do without any difficulty. So that's what the integration by parts usually does, is it makes something that was difficult into kind of a weirder expression, but this is now something we can do. And so let's finish it. So x e to the 3x, the integral of e to the 3x would be e to the 3x over 3. And then now we do the plus c at the end. Once you have no more integral symbols, just throw that plus c at the end. And there we go. Okay, and so now I'm just going to put it to the side. Just like always, you could check by doing the derivative. All right, if we check with the derivative, the first part would require the product rule. It would be 1 times e to the 3x plus x times the derivative of e to the 3x, which would be 3e to the 3x. And then minus this derivative, which would be simplified into just minus e to the 3x. And then the derivative of c is 0. Well, when checking, this would simplify and cancel with that. And then we're left with just the middle term, which matches what we started with, just not in the exact order yet. Okay, so it shows that we did it correctly. All right, so anyway, so that's typically how it's done. So if you have an exponential, usually you want that to be part of the dv. Polynomial is your u. Okay, so let's set this one up. All right, so if I were to try a regular u substitution, it would not work. But I'm still going to kind of mark things. We're going to do integration by parts. So it looks like this is our two split ups. So I'm going to say u, again, is usually the polynomial portion. So the 4x squared. And that means du would be 8x dx. And then dv is the other part that we need, which is the e to the 5x plus 3. And then dx is attached. Okay, and then with our v, okay, so to find v, the antiderivative of an exponential is itself e to the 5x plus 3. And then with this, it really is just the constant rule. The 5 is attached to x, so that means we have to divide by the 5 to get it set up correctly. Okay, and then, oops, no dv needed afterwards. Let's just do it like that. Okay, and then again, you could always do a very, very quick check. So this was doing the antiderivative. If I go backwards, if I do this derivative, it does match what's above. So the derivative of this is that. Okay, so we do a quick check, but notice it is really just the constant rule, 5 times x. I'm just dividing by 5 because the 3 constant doesn't really matter when doing those antiderivatives. Okay, anyway, so we have our u, du, and dv and v. Remember, check when needed. Okay, but now the way I usually set it up, so on the previous one I set up u and v, I usually just go straight to equals and doing my diagonal. So these will multiply each other. Okay, so I've got 4x squared times the e to the 5x plus 3 over 5. And then always minus the integral of these ones multiplying each other. Okay, so this one gets double action. And it doesn't matter the order. This one has dx on it, so it should probably be last. So let's put this one in the red first. So we have e to the 5x plus 3 over 5, and then the 8x dx. Okay, and then now it's look at it and simplify. So in our first one, all I'm going to do is just put the 4 and the 5 together as 4/5. So we got 4/5, and then x squared e to the 5x plus 3. And then we have minus the integral. I'm going to do something similar with the 8 and the 5 as 8/5. 8/5, and then let's put the x and then the e to the 5x plus 3. And then dx. Okay, so now looking at this, I still have an integral right here, and it looks like I still need to use another integration by parts. So if this integral is not super easy, like in the previous problem, we could just do it in one step. It usually means to do integration by parts again. Okay, so one more time. So this one's not a basic one. Not basic. So do integration by parts again. Integration by parts again. Which means just set up your u, your du, and your dv and v all over with what's in here. Okay, so to split it up, again, the polynomial portion is probably the u, so I'm going to say that right there. The 8/5 x is the u, and then let me fix that 5. So 8/5 x is probably the u, and then the du then would be 8/5 dx, like that. And then the e expression is usually the dv. So e to the 5x plus 3, and then the derivative, or the antiderivative of this, is itself divided by the constant that's attached to the x. There we go. And again, we usually don't put plus c on this. We just wait till the very end. All right, and then now let's set this up. Oop, might be running low here. Okay, so I have 4/5 x squared e to the 5x plus 3. So notice this part's done. I just need to rewrite it. And then here's where we have to be careful, though. Let me use green. So this whole thing will be minused. So let me put minus, and then let me get that green bracket to start, and we'll hopefully have enough room. Okay, but at this point, I'm going to do my diagonal multiplication. Okay, so this whole thing in the green, I'm still doing integration by parts, where those two multiply. Oops, let me not draw over it. Okay, so these two multiply. Okay, and the order doesn't really matter. You can just put in whatever, but let's put the parentheses. 8/5 x times e to the 5x plus 3 over 5. And then minus the integral. So it's always minus the integral. So I'm just following that formula. This one and this one multiplied. Okay, and just like before, maybe just let's put the e expression first. Times 8/5 dx. And then the green bracket at the end of it all. Okay, so there we go. And I kind of wasted too much room. Okay, so I am going to just kind of go into the next page. So sorry about that. If you write smaller, I don't think it would be an issue. But what we're going to do is just simplify. We've got 2 more steps, I think. We're going to simplify this here. So those constants just all multiply and would stay in the front. And then let's also distribute. So I'm going to highlight it in pink and just say, hey, that should become a negative and that should become a positive. So we're going to do a couple things in one here. So equals. So 4/5 x squared e to the 5x plus 3 is just copied. And then it now is minus this thing in the blue, but 8. 5 times 5 is 25. So 8/25 x e to the 5x plus 3, like that. And then we had minus a negative, but it would become plus. The integral's still there, but let's simplify one last thing. The 8 and the 5 would be 8/25. And then now it's just the exponential e to the 5x plus 3 dx. Okay, and now this is now a basic one. This integral is just using the constant multiplier on the power there of e. So we're just going to have to copy and paste and then multiply. Okay, so what we have, these first two are good. So there's no integral sign. So that means just rewrite them. So 4/5 x squared e to the 5x plus 3 minus 8/25 x e to the 5x plus 3. And then we have plus, okay, we could do this antiderivative now. 8/25 is just hanging out. Copy and paste the e expression, so e to the 5x plus 3. And then, again, divide by the constant multiplier on the x, so over 5. And then now that there's no more antiderivatives, or no more integral symbols, it would be a plus c at the end. Okay, and so that is our answer. We will just have to rewrite it one more time. There's one last thing. The 25 and the 5 would multiply. So let's end it. So we have 4/5 x squared e to the 5x plus 3 minus 8/25 x e to the 5x plus 3 plus 8/125 e to the 5x plus 3. Plus c at the very end of it all. Boom, done. Okay, so that's how these problems break down, and I'm not going to do it because it'll take a little bit too much time, but you could check by doing the derivative. So this would require a product rule. This would also require a product rule, and then do that one eventually, but it will match what we started with. It will work. I guess I'm being confident there. I'm assuming I made no mistakes. Okay, so, but this should, if you did the derivative of this, it should match our beginning integral. Okay, so that's it for now. So that's what we do with the exponential ones. If you have e to something, it's usually set your u as the polynomial and your exponential portion as the dv. Make this table, then cross, multiply, kinda, and then set it up with your formula. Okay, so that's that. So we'll do a couple more in other videos with different functions. But if you have questions, let me know. And thank you for watching.